Hi, this is another video for my GCSE Electronics students. We are studying microcontrollers, programming of microcontrollers in Circuit Wizard, and in the previous video I posted a solution to this example one, solution one. So I showed you how we can implement this using Circuit Wizard, and we built this circuit like so. And we noted, or hopefully you noted, that the flowchart was, or it had issues, okay, not necessarily problems, but it had issues. So there were, by the way, there were two LEDs connected to, here it says B0 and B1, but we found that using the junior microcontroller, we just had to call them G0 and G1. That's not really significant. But what we found is that, well, first of all, the program only runs once because it goes from the start, sequentially runs through these things, and then goes to stop. That might be an issue. So that's one of the two issues that they note there. And then also, sometimes it does need to do, say, turn an output off and then turn another output off. And it's currently doing that sequentially, like turn output B0 off and then turn output B1 off. So it's doing those in sequence, whereas it would be much nicer just to update those two outputs at the same time. So that's what we're going to be doing. We're going to modify this solution to be now solution 2, and we're going to implement it using Circuit Wizard. And let's just have a quick look at this. You'll notice that rather than having a stop or an end, no longer does, because you don't have to have a stop terminator. You can just wrap it around, so it just loops around. There's no reason not to do that. And the other thing as well, it's got one of these boxes which is modifying multiple outputs. In this case, it's going to be turning B0 and B1 on simultaneously. So we're going to do this, but we'll do it in Circuit Wizard, so it's not going to look absolutely the same. So let's go to the flowchart view. And if, by the way, if previously you've made this circuit and you did the flowchart for solution 1, you can just copy and paste it into a new document. And so we've already got the start block, and then so we're going to turn output, well, G0 on. So we're going to send G0 to logic high, or set it to logic high. Then we'll have a delay of 5 seconds. So I'll just type 5 now. By the way, I'm doing it this way because this is the way that it's shown in the book. Actually, I would personally prefer just to add the wait here, and then that means you can avoid having this second block, but we'll do it this way just for the moment. And then turn output G0 off, so we're going to set that to logic low. So G0 is now going to go off, and then have a 2-second delay, so I just control drag, change that to 2 seconds. And then I want to turn the two outputs on simultaneously. Now to do that, I need to use this outputs block here, and I need to change G0 and G1 both to be on now. 0 means logic low or off, and 1 means logic high or 1 or true on. Okay, and then so we want G0 to be logic high, and we want G1 to be logic high, like that. By the way, if you were to click once more, it goes to T. T means toggled, and that means that it will flip the value. So if it's currently off, it will then go on, or if it was on, then it will go off, like that. But unless you know the previous state, you can't really use that for sure. So anyway, so let's just set those both on, and then we'll have another delay, a delay of 3 seconds. Change that to 3, like that. And then we're going to turn those off. Now, to turn them off, I just drag that down. And to turn them off, it's going to be 0. Now, the cross, by the way, the cross doesn't mean off. It just means don't do anything, no change. Okay. So we want G0 to be off. We want G1 to be off, as they are now. And then we need to wrap this around to the top. Now you can pull out from the side. By the way, you could pull out from the bottom and then go around like that if you wanted. It's up to you, but I'm going to go from the side, and I'm going to go there like that. Now, I see quite a lot of people, and that's how it's shown now. I see quite a lot of students do it slightly differently. There's always a tendency for many people to do it like that. I tend not to like that because to me that's inferring that there's a complete hard restarting or resetting of the microcontroller. It's not actually going to make any difference in this particular case, but I think it's better to say, well, look, my microcontroller only starts the once, but the code within that program is looping multiple times. Okay, so hopefully that makes sense. If it doesn't really matter too much if you loop back to the start block, but I would avoid doing so. Now, hopefully that's right. Let's skip the checking. I mean, really, you should double check through, but let's just see if it works. So it's a bit difficult to keep track here, isn't it, of course? So what we could do, we could just show the flowchart program, and we could zoom in a little bit. So we're waiting 5 seconds, and then we turn both them they're off, and then wait for 2 seconds, and then turn them both on, and then wait for 3 seconds, and then turn them both off, and then set G0 high, which is the red one, then wait for 5 seconds, then turn it off, and then wait for 2 seconds, and then turn them both on. Yeah, that seems to be working fine. Okay, now don't forget, you can also check by going onto the flowchart sheet, and when you run the simulation, you can view the digital inputs and outputs, so you can see it that way as well, and you'll see those updating like so. Okay, so now we've made that, so that seems to be working okay. And so the next thing you should do is read through this text, just noting anything down there. I'm not going to read it for you, that's just a waste of your time. And here, so now investigation 4.1, you've got to do the write up now. So construct a flowchart program shown in example 1 solution 2. Well, we just did that and we've tested it. Show the output pins used for each output of your chosen micro. Okay, so you've got to do this. So what's your chosen microcontroller? Well, I chose a Genio 8. Doesn't have to be Genio 8, but it makes sense to use the least powerful, least featured microcontroller when you only need to use 2 outputs. You could use like a Genie 18 if you want, but it's more expensive, it's got more pins, and it's just unnecessary really. So yeah, so here microcontroller like Genie 08. Red LED is connected to, well, that was G0. Blue LED is connected to output, and that was G1. Does the program perform the correct sequence? Yes, it did. Okay, and now what you now need to do is you now need to have a go at question 2.